All right, we are in geometry, lesson 15-2. Today's date is April 16th, 2019. April 16th in blue, April 16th, 2019. Make sure your name and date are on your paper. Some people don't put their name and leave their notes here and have to try to play Sherlock Holmes, figuring out whose notes they left. All right, so factoring in 2 steps. I promised you that this was copy-pasted from yesterday. Here it is now. And I never passed out the cards. Still, actually, yeah, thank you. Quiet raised hand. What are the 2 steps for factoring any quadratic? Factoring any quadratic. Copy pasted from yesterday's notes. Just look at yesterday's notes. I see 1 hand, 2 hands. Only 2 people remember this from yesterday. 3 hands. Go for it, Cheyenne. Yep, factor out the greatest common factor, so GCF. And then step 2, Ninja Star, there it is. All right, everyone write it down in your notes. Let me pull up the marbles as well. First, we factor out the greatest common factor. That was yesterday's lesson. Today's lesson is step 2, Ninja Star. Tomorrow's lesson is also step 2, the advanced Ninja Star. So coming back here, Cheyenne, this is period 1. Go to geometry, and Cheyenne, there you are, 50 XP, and I have your card whenever you get that. All right, so distributing versus factoring. Yesterday we had, oh shoot, this is still not quite right. All right, everyone make this addition to your notes, well, subtraction, I guess. Get rid of this 2, scribble out that 2, that shouldn't be here, that should be tomorrow's lesson. We should have the problem x plus 3 times x minus 5. Scribble out that 2. Don't know how that happened, but okay, so going through this, multiplying these together. Who remembers doing this from Unit 14? And who can volunteer to tell me how to either FOIL or box this out? India, go for it.
You want to take the x in the first parentheses, and you want to multiply it by the x and then negative 5 on the other parentheses.
Okay, can you do those 2 for me? And I can let someone else do the other 2?
X squared, and then it's going to be
Minus 5x. And you are foiling it out for us. Thank you. So you did the first 2 steps. Thank you, India, Marble, and XP. I think you can just drop them in there. All right. Who can do the other 2 steps for foiling? Samantha, go for it.
you multiply you get plus 3.
Plus 3x. Minus 15. Perfect. All right, thank you, Sam. And then I need someone to do the final step of simplifying. We foiled it out. Now we need to simplify. Beverly, go for it. There it is. Thank you, Beverly. And box our answer. That is our final answer.
We have a late person here.
All right, so from here, we need to go backwards. The trouble with going backwards from doing this hard foiling problem is that it is hard. So the way that we're going to solve this is using this tool I'm calling the Ninja Star. It looks kind of like an X, so if you want to call it the X, which is less cool of a name, then you can do that. So when are you going to use this tool? When are we going to use this tool? We're going to use it whenever we have a trinomial or when the leading coefficient is 1. And make a note here that this 1 is a positive 1. So we'll do like a plus in front of this. It has to be a positive. Every single time it has to be a positive. This is the case regardless of what happens. Tomorrow I'm going to show you what happens when we have a positive 2 or a positive 3. Regardless of what happens, the most important thing to take away is it has to be positive. What is a trinomial? Can someone quietly raise their hand? What is the definition of a trinomial all the way back from Unit 14? We defined that. Of a positive 1, yeah. What is a trinomial? Quiet raised hand. Who remembers what a trinomial is? Beverly, go for it.
It's like 3 coefficients.
It doesn't.
Like, it's like that right there.
3. It's like this thing right there. Yeah, 3 terms. three terms, there's these little segments separated by pluses and minuses. So these three things mean I have three terms or a trinomial. So whenever you have three terms, that's generally when you're going to use this ninja star. Although that's not 100% of the time that you're going to use a ninja star. In Algebra 2, we'll use ninja star on binomials and never a quadnomial, I guess, a 4-degree term. Usually a trinomial or a binomial. Okay, let's go ahead and start learning how to use this function. Let me not forget Beverly participating and Marble. All right, so I wrote out the steps for you. You have step 1, 2, 3, and 4. So with this problem, I'm going to start using this problem, x squared minus 2x minus 15. I want to now go backwards. Again, unit 15 is going backwards from unit 14. This is going to be my b term, write b underneath the negative 2, write c underneath negative 15. I'm looking at this form, x squared plus bx plus c. Therefore, my b and c are going to be negative 2 and negative 15. I need a quiet raised hand. How do I fill in this ninja star? What goes where for the ninja star? Just read the steps. I need someone to do step 1 and step 2 for me. I know what my b are. There's no x terms yet. I don't put any variables. I'm just looking for the coefficients. Go for it, Anna. Where do they go? Oh, so I'm just looking at this guy right here. There's too much talking going on back there, Jane.
I don't know.
All right, so c goes on top. I'll help you out. So this is our c term, negative 15. Yeah, negative 2 in the bottom. Thank you. Yeah, so you have set up our ninja star. Everyone write it down. This is how you set up our ninja star tool. All right. Moving on from here. I'm going to find two numbers that multiply to the top and add to the bottom. So I'm going to do this sign. You don't have to make the sign. I'm just going to make it for clarity. These two things have to multiply to the top, so I'm doing a multiplication symbol on the top, and on the bottom I'm going to do a plus symbol. They need to add to the bottom. This is to help you to remember what goes on the top, what goes on the bottom. The way that you want to start thinking about this is what times what is negative 15. So I'll shout one out. Ready? Negative 1 and 15. But those two numbers also have to add to negative 2. Negative 1 and 15 don't add to 2, it adds to 14. Can someone think of two things that multiply to negative 15 and then also make sure that they add to negative 2? I see Beverly already has them. India has them. Caroline has them. What times what is negative 15? That also adds to negative 2. I see Anna has her hand raised. I need more hands here. This is one of the hardest parts of today's lesson. Does anyone still have their card? All right, we're trying to find two numbers that add to negative 2 and multiply negative 15.
Where'd you get negative 15?
I'm solving this problem right up here. All right, go for it, Caroline. Negative 5 times 3. Those are our answers. We write the answers for step 4. Or I guess we're just still on step 3. On step 3, we're writing the answers on the left and the right. So, reviewing. We started with this problem, x squared minus 2x plus 15. We wrote this b term, this negative 2 term on the bottom. We wrote this c term, negative 15, on the top. From there, we solve this problem by saying what multiplies to negative 15, adds to negative 2. We write our answer, negative 5 and 3 on the sides. And then from here, we write it in the correct form. I know that from here, x squared minus 2x minus 15 should have x plus or minus something, x plus or minus something. Let's write that now. This should be x something, x something. I know that I'm going backwards, so I should have an x and an x. And I already solved what I should be having over here on the sides. It should be a binomial. I should have another term right here. Well, the binomial is minus 5. So my first term is x minus 5. That is going to be multiplied to x plus 3. I'm taking the sides of the ninja star, the solution of the ninja star, and I'm writing it in the correct form. Notice that our answer here that I'm now going to box, our answer here is what we started with. We started with x minus 5 times x plus 3. We went backwards. There were a lot of steps. I'm trying to make it as straightforward as possible. I gave you all the steps, 1, 2, 3, 4, how to do the ninja star. We'll try it over and over again if you still don't get it. Let me see your fist of 5. How well did you follow that first example for the ninja star? I see a 0, a 3, a 2, a 3, a 3. You can make a 3.5 if you want. Let me see that 3.5. I see 3, 3, a 5, a 5. All right, let's try it again.
Wait, you do negative 15 and then negative 2, but like, I don't get like, what, guess negative 5.
Mr. Sindel. Wait,
So I have to find, the question was, what times what is negative 15? So I'll give you an example. 1 and negative 15 is negative 15. But those two numbers that I found also have to add to negative 2. So okay, so negative 5 times 3, do you agree that that's negative 15? Do you agree that negative 5 plus negative 3 is negative 2? Those are the only two answers that I can get. And you can write them on either side. Question, Beverly?
For like example 1, do you have to like do the problem first and then you have to go backwards?
So for example 1, I only showed you going forwards and going backwards to relate unit 14 to unit 15. All we're doing right now is going backwards, purely backwards. So in example 1, everyone write your ninja star. Everyone make your ninja star. I need a quiet raised hand, hopefully with a card, that tells me what number to write on the top, what number to write on the bottom for my ninja star. We're just doing ninja star over and over and over again today. I see one hand that can help me set it up. 2 hands, 3 hands. Who can help me set up a ninja star? I'm looking for someone with a card. Ellery, go for it.
You put 6 on top and 5 on the
There it is. 6 on top, 5 on the bottom. Everyone write it down in your notes. Thank you, Ellery. And now your card is in. All right. This is the hard part. What times what is 6? They also have to add to 5. What times what is 6? That also adds to 5. Emily, go for it. There it is, 3 and 2. 3 and 2 do multiply to 6, and they also add to 5, so those are answers 3 and 2. I now need to write this in the correct form. All right, thank you, Emily. And there's your marble. Who can write this in the correct form now? The correct form should look like x something, x something. You should have 2 binomials multiplied by each other. Who can write that in the correct form? Anna, go for it.
X6 plus X5.
Ooh, careful. So we're going to use the left and the right.
X3 plus X2.
So x3, is there a number that, or is there an operation that goes in between
X
there?
plus 3
Okay,
plus parentheses and then X plus 2.
there it is, x plus 2. Thank you. And that is the final answer. Box it. That's as easy as it gets. Those 4 steps over and over and over again. Thank you, Anna.
Mr. Sindel,
Yes,
you know Drew has a private tutor?
I did not know that.
I don't have a private tutor.
He learns it here. He like doesn't learn here. He just does it.
Oh yeah.
All right. Give me a fist of 5 on example 1. How well did you follow example 1? Really quickly. Oh man, yeah, you guys are getting much higher numbers. We went from a 0 to a 5, a 3 to a 4, a 3 to a 5. All right, awesome. Let's go to example 2. Again, I have to make sure that my leading coefficient is a 1, and it is a 1. So I can directly do the ninja star. Set up your ninja star. Someone help me. What goes on the top? What goes on the bottom? Martine. There it is. Minus 15 on the top, 2 on the bottom. Thank you, Martine. Martine's on it. There's your marble, Martine. All right. Now the question becomes, what multiplies to negative 15? That's the first question. Then make sure that the 2 things that you find also add to 2. What times what is negative 15? Ooh, negative. That means one of them is going to be a negative. One of them is going to be a positive. They also have to add to 2.
Well, which is going to be negative?
Yeah, that's a good question, right? What is it going to be? I see only 2 hands, 3 hands, 4 hands, 5 hands. Is that a hand, Loretta? Half hand? Is it a question hand or an answer hand? What's up? Not raising your hand? Okay. All right, India, go for it.
It's going to be 5 times negative 3.
5 times negative 3. There it is. 5 times negative 3 is indeed negative 15, and 5 minus 3 is 2. The more we do these, the better practice we'll have, the better we'll be able to do these problems. So India, you have it correct. Thank you, India. And then from there, who can write this in the correct form? Sam, yeah, go for it.
So it's parentheses, x plus 5, parentheses, and then x minus.
Well said. Yeah, thank you, Sam. And that is our final answer. We will box that. All right, there's example 1, example 2. Seems like most people are following pretty well. All right, now a harder problem. I told you guys at the very beginning of lesson 1 and the very beginning of this lesson 2, there are always 2 steps. We were only doing step 2 over and over again. Now we're going to do step 1 and step 2. Step 1 is finding the greatest common factor and factoring that out. And then we're going to do that ninja star that we've just got some practice on. So, greatest common factor. What is the greatest common factor of 2x squared minus 20x plus 48? I'm looking for the greatest common factor and for someone to factor that out. A lot of people are thinking, oh shoot, greatest common factor. That was yesterday. I forgot that. How do I do that? Maybe look back to your notes. What are you going to do? Greatest common factor. Ellery, go for it.
So the greatest common factor will be 2.
It is 2. And when I factor out that greatest common factor, what do I have left over?
So you'll have x squared minus 10 plus 24.
Like that?
Yeah.
There's a tiny error. I'll let you find it.
Minus 10. No, but the x would go away, right? Because the 2 used to be. Never mind. 10x. Sorry.
No, that's good. Yeah, so if there's no x out front for the greatest common factor, you leave the variables alone. If there was no variable, leave no variable. If there was an x, leave an x. If there was an x squared, leave an x squared. Good job, Ellery. All right, Ellery has her 50 XP and her marble. All right, we have factored out the greatest common factor. It was an easy common factor. It was just 2. And usually for these ninja star problems, I'm not going to make it too hard. I won't give you 14 for a greatest common factor. I'll probably make it 2, 3x, at the most maybe 4x squared, but nothing bigger than that. I'm not going to do 15x to the power of 100. All right, we just did step 1. Step 1 was the greatest common factor. Step 2, ninja star. I need to do a ninja star just on this guy. So set up your ninja star. I'm going to use the space out to the right. Ninja star. Again, quiet raised hand. What goes on the top? What goes on the bottom? Same thing. Over and over and over again. We will get this down. Oscar, tell us what goes on the top and bottom.
4 and -10.
Which one goes where?
24 goes up top and -10 goes down.
All right. Thank you, Oscar. Oscar set up the ninja star for us.
Yeah, Oscar.
Now the hard question. What times what is 24? That's the first question. What time? Well, 24 and 1, that's not going to help us though. What times what is 24? That also adds to -10? What's going on here? How can I get a negative? Lots of people already have answers. Oh my gosh. Lots more people. Yeah, Emily, go for it. Yo, you're so close. 4 and 6 do make 24, but how do I make a -10? How can I change both your 4 and your 6 to make a -10? -6, now I have a -2, and also the 4 as well, so a -4 and a -6. Yeah, good job, Emily. So a -4 times a -6, a negative times a negative is indeed a positive 24. And then when I add the 2 negatives, I get a -10. Thank you, Emily. All right. And then this is the second trickiest thing that I can give you. If you factored out the greatest common factor of 2, it's still there. It doesn't go away. My Algebra 2 students still make this mistake all the time. That 2 is here. I'm going to leave that 2 factored out. Now I'm going to have 2 binomials. That 2 is still factored out, but this ninja star helps us to get these 2 binomials multiplied. Tell me what that correct form is. Beverly, go for it. Oh, x plus, okay, x minus 6 and there it is. That is our final answer with the 2. The 2 is factored out. It stays there. I say that over and over again because most people will forget that. You'll forget it on the homework or the test or something. You'll forget it in Algebra 2. I want to make awesome Algebra 2 students. Thank you, Beverly. All right. Ooh, this one is a little bit tricky. Oh, you have a question?
Yeah, I'm just wondering, like, where does the stuff apply?
we're solving this so that we can get to quadratics. So quadratics is the study of how U shapes are made. When we factor, what we're really finding here is X intercepts. If I need to graph a U, where does it cross the X-axis? Right here at -4, right here at -6. In fact, it would be actually +6 and +4 because of a rule I haven't told you about, but it's finding X intercepts, which are super valuable because say you're trying to, I mean, I'm sorry to say this, but math has a deep history with killing people. Say you're trying to kill maybe some target, not a human being. You're trying to destroy a target. You need to figure out exactly where your cannonball is going to land. That is an X-intercept. To find where your cannon is going to land, you need to use a quadratic. Quadratics have X-intercepts. To find those X-intercepts, you need to be able to factor that. So when you go into physics and you see an X-squared function, you're like, oh, I did this with Mr. Sindel. We've shot cannonballs and we used the X-intercepts by factoring our quadratic. These represent where you fire the cannonball from and where the cannonball hits. If you want to kill a target, I guess. Of course, if you need to actually kill bigger and meaner things, then you can do that as well. If you want to talk to me more about the history of math and killing, it is people, unfortunately, throughout history, I have a giant hour spiel that I can give you. Martine.
When will I use this?
If you need to improve your basketball skills. Hopefully, if we have enough time at the end of quadratics, I'll show you how quadratics applies to making your basketball skills better. For example, when you shoot a basketball, it follows an arc. An arc is a parabola. A parabola can be modeled with this quadratic. I can improve your accuracy when you shoot the basketball when I can model this quadratic and figure exactly what your entrance angle is for the basket. Randomly speaking, this is kind of going on a tangent here, but if you shoot it with a 45-degree entry angle, you have a higher % chance of making a shot than with a 30-degree entry angle.
Wait, Mr. Snow, did you make a video?
We have videos from last year doing this, yeah.
Can we watch it?
We can watch it after we finish the notes.
Yeah, we should watch it.
We need to do example 4. Example 4 has a problem. The problem is the leading coefficient is not 1. The leading coefficient is that first coefficient. The first coefficient needs to be a positive 1. I have a leading coefficient here of -1. How do I factor out so I have a positive 1? What do I factor out? Lorea? By -1, right? Yeah, so it's kind of like multiplying every single thing by -1, but we're not allowed to do that because we don't have an equal sign. So what I can do instead is factor out a -1. And here's how it's going to look. -1 is being factored out of a giant trinomial. What I'm going to do here is I'm going to divide each and every 3 of these terms by -1. So first I'm going to say, what is -x squared divided by -1? And I need someone to tell me what that is. What is a -x squared divided by a -1? This is really, what is a negative divided by a negative question, Anna? Positive x squared. Yep, there it is. A negative divided by a negative is now a positive. And hey, that's what I was looking for. I was looking to make sure that I had a positive 1 for the leading coefficient, and now I have a positive 1 for the leading coefficient. That first coefficient is the leading coefficient. But now I need to divide each and every one of these by -1, which is the same thing as saying switch the signs. This was a positive 5x, now it's a negative 5x. This was a positive 14x, it is now a negative 14x. So we factored out a negative so that the ninja star would work. If you don't do this and you try to do a ninja star with a negative out here, it will break the ninja star. If you try to factor it, it won't work. And that'll be fun to try on your own, but I'm sure some of us will make that error and be like, Mr. Sindel, this isn't working. I'll be like, you forgot to factor out the negative. Ninja star, here we go. Easy points here. Top and bottom, who can set it up? India. -14 and then -5 on the bottom. There we go, India. And then I need to figure out what 2 things multiply to -14, what 2 things add to -5. One hand up, 2 hands up, 3 hands up. Caroline, go for it. -7 and 2 is indeed the correct answer. Thank you, Caroline. And finally, who can write the entire correct answer? Yes, Sam.
It's -1.
Ah, you Got the -1. I thought you would forget that.
X minus 7. And then parentheses again, X plus 2.
Very well done, yeah. Oh my gosh, you remembered her box and everything. There it is. That -1 didn't go anywhere. It is still there. You are doing the same exact thing for example 5. And I will give you this hint before you go and do example 5 on your own. Whatever the leading coefficient is for tonight's homework, that will be the greatest common factor. This was a -1, you factor out a -1. This was a 2, we factor out a 2. That is going to help you for what you're going to factor out for this next trinomial. That hint won't apply to tomorrow's homework, it'll apply to only tonight's homework, but generally speaking, just factor out that first coefficient. All right, so you're working on example 5 by yourself or with people around you. Once you finish example 5, we will go back through the solutions really quickly, but you can immediately start on the homework after example 5. All right, quite raised hand. What was the greatest common factor and factor that out for me? Colby, yeah, you want to try it? You didn't have your card turned in though. Okay, Anna, go for it.
So the greatest common factor is 3.
Yep.
So you would get -3, then x squared, then plus 3x minus 4.
Perfect, yeah, thank you, Anna. And if I come back here, Anna, 50 XP. All right, I need someone to set up the Ninja Star for me. Quite raised hand, that's easy also. Ninja Star, what goes where for the Ninja Star? Go for it, Caroline. Perfect, easy points, thank you, Caroline. And then from there, what times what is -4 and also adds to +3? Emily. 4 and -1, thank you, Emily. And then to finish off our notes, what is the final answer? Jane, you want to give it a shot? Final answer.
Okay, this is what I got. I got -3.
-3.
Parentheses. X plus 4. Parentheses. X take away 1. Parentheses. Box. Triangle box. Triangle.
Yeah, so that is correct. Thank you, Jaden. And that concludes our notes. I want to see FIS of 5 at the very end of the notes. How well do you think you can do examples 4 and 5, those types of problems? I'm seeing 4s, 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 5s, 4s. Yeah, that's a pretty high score.
I have a question.
Yeah, question.
Does it matter if like the 4 and the 1 are like switch box?
It doesn't matter, yeah. You can switch these two. It doesn't matter what side they're on. Same thing with these two. These two can be switched back and forth. Yeah, good question. Any other questions before we write our summaries and do our homework?